So yeah, Dan Jenkins, all the way from Boston, in England, or England, to do a talk first tonight. So give it up for Mr. Jenkins.
Hi everyone. So yeah, the talk is titled "Bringing Chaos to Order in Your Node.js App," which is really, really vague, and it's kind of designed to be that way. So who am I? I started up a company 18 months ago called Nimble8. I do a load of consultancy type work. I've been working for the past year on something called Bespoke, which is WebRTC. But yeah, just quickly, I'm a Google developer expert in WebRTC. There's only 275 of them in the whole wide world. I love Lego. I love Technic. One of my friends has stolen all my Technic and is making a Node module to control the Technic. It's really cool. General geek, founder of Nimble8, and I love open source. And over the past year, I've really craved more open source because I haven't been able to. I'm Dan Jenkins on GitHub. I'm Dan_Jenkins on Twitter. Follow me. I tweet a load of interesting things, I think. Anyway, I'll skip through that. So we offer consultancy type things and training and things like that. Get in touch if you want. So why do you want to listen to me about Node? So I started with Node when it was a baby. I started when it was 0.4. And over the years I've built many microservices, many REST APIs, a load of real-time type things. And yeah, the last year I've been helping build a platform called Bespoke, which does a load of WebRTC platform as a service type things. So, funny story. I entered into getting a ticket into Google I/O, which I'm sure 90% of this audience did. And obviously I got back my email and said, no, you haven't been successful. And I went, okay. And then I organised to come over to Ireland for Node.js Dublin. 3 weeks ago I got an email from Google. Here's a code. And I was like, oh, I've already said that I'll do Node.js Dublin. I can't go back on it. So I had a ticket to Google I/O, and I'm here. Oh, I wasn't really, I'm not bragging. It was pure luck, but yeah. So hopefully, as a Google developer expert, I'll get to go next year, which is cool. Okay, so a warning before we have a look at all this stuff. There are some bad practices in all my slides. It's all designed to be really simple to read, and that's why some things are just, it's not how you would do it in production, but it's designed so that you can have a look at it. Yeah, I know you shouldn't do it, but it's easier to have a look at. So Node apps can get in a real mess really, really quickly. Out of curiosity then, so how many people here are actively developing with Node? And I'm hoping most of the hands in the room go up. Okay? How many of those have put something into production? How many of those are still in production? Okay, cool. So the guys that are running stuff in production should know that unless you're careful, things can get messy quickly. So, okay, it's good that we got the back screen one. So you can see here, it's a controller of some description, and it's creating an administrator in a model, and then we start adding some stuff to the response object, and then we might send some data into that function, and then that function might change that data, and then we end up responding with the data that's attached to res. Everyone has probably done this at some point. Abused the rec and res objects, for example. There's many other examples. So this one is doing something very similar. This one is passing an ID through loads of functions and then eventually using that data to log out some data And then responding at the end of it. But we've had to pass the ID that we want to log at the end all the way through all of our functions. And things start getting very messy. So everyone's done it at some point. Everyone has, don't try and deny it, everyone's done it. So what problem are we trying to solve here? So the problem is that we're passing data around, and you might pass data 5 or 6 layers down to then be able to send that data to another service or some extra data against that. And then yeah, it essentially gets really kind of messy. You're passing things around and you don't need to. So this is an example. I'm attaching an ID, and then I'm passing rec in this instance all the way down, and then at the end I want to log when something happens. And because I want to tie up the request with the ID of the request, with whatever happened, I have to pass it all the way along. So a great example of this is service-based logging. So when I write microservices, we generate a request ID at the very top level, and then we want to send that request ID to all of the microservices, so that when we look at all of our logs, we can go, oh, so we know this request failed, put it into like Logstash, Kibana type stuff, and see exactly what happened in like this service then called this service, this then called this, and oh, these two don't match, and that's how you end up figuring out what issues are. So what's the answer to all of this? Cats. No. I had to get one in there. So there's a module called CLS, Continuation Local Storage, on NPM. And what that does is solves this. And that's what I'm going to talk about a little bit. It's very specific, but not many people have actually heard about continuation local storage. So it's a userland module. Like Rod was saying, a lot of stuff we don't want in core, we want core really small. It utilizes the async listener module. And yeah, it's really nicely kind of modularized. If you take a look at continuation local storage, it's one file, and it's something like 300 lines long, I think. It's really, really small. I was amazed by how small it was. So it has nothing to do with local storage in the browser. That was my first thing. I was like, well, how is this utilizing local storage that's in the browser? Because Chrome doesn't have that. It's just called local storage because that's how it's described within other kind of programming languages and structures. So I've taken this from Forrest is the guy that made it. He now works at NPM. So this is off of the README out of the project. So continuation local storage works like thread local storage in threaded programming, but it's based on chains of no-style callbacks instead of threads. So basically, it means that you don't have to pass all this data or add it into something that it shouldn't have even been in the first place, which means that you can actually start to kind of get back control and make your application do what your application is actually meant to be doing in the first place. So, so this is an example from earlier, where you've added an ID onto res, and you're passing res into your respond function, and then the respond function logs out what the ID was, and then you respond. So that's, I'm really sorry, it's a really bad example, it's a really simple example, and you're like, well, that's really simple. But when you think about production running apps and you've got hundreds of files, possibly, in like a main API, all of this is kind of scattered around, and it becomes really, really, really unmanageable. And this doesn't show how unmanageable it can become. Like, so you want to add, if you've gone down the route of, oh, I'm going to pass the ID along all the way down, and then 5 weeks later, someone comes along and goes, well, we don't need just the ID. We need the customer's email address to be passed all the way along and in all of our log messages. So you've now got to go and change all of that kind of function loop, the function stack, to accept that email. So you're constantly changing code. So you can start doing nice things like this. So you can require in continuation local storage, and you can create a namespace. So namespaces are alive for as long as the original function that created the namespace is alive. So let's take that in terms of an HTTP server. When your request comes in, you've got a function that does stuff and routes the HTTP request to other functions. So you attach your CLS stuff at the very top, and the namespace will always be available to the rest of that request. And then eventually that original function will die because the request ended. So that's how this all works. So you can create a namespace. In this instance, I called it request life, and you can set information within that namespace. So namespace.set, I'm setting a request ID, and then later on, I'm just within the respond function, I'm getting that data out of the namespace, out of the continuation local storage. So you can really think about this as like a mini session per life of a function. That's the best way of talking about it, really.
Sorry, you're creating a namespace in a module scope. Surely every single request gets the exact same namespace.
No, so I knew this question was going to come up. It's within... yes, I think you're right. I think earlier on I was doing it wrong when I was writing out my slides. Basically, you create the namespace within the request. So namespace should actually be down here. Yeah?
Cool, yeah.
Yeah, sorry. So it's more impressive than it looks in this simple example. I keep saying this. It looks really, really simple, and why do you need to even do this stuff? But think about files that depend on files that depend on files, and at the end of your 5th file with your 10th function, you want to log something out, or you want to do an HTTP request to another service. So what do I need to do to use this? So you require in continuation local storage, you create your namespace, which we've discovered is in the wrong place. In this example, it's not. Session.set and then session.get. And so in this example, what this is doing is it's fetching a user, and then it's setting that user. And then in another function, you want to get that user. So instead of passing it around, you don't have to. Or you don't have to do a second request to your database. You've got that data one time, and you set it into your session. Yeah, I'm going to call it a session. It's a session for your function life. So it just works. Yeah? Well, yeah, kind of. Mostly. So beware of native interaction. So anything that requires a native module, a module that has native bindings, you'll need to do something called shimming. So MySQL is a great example of this. So Felix is an MySQL module that has some bindings underneath it. And if you don't shim it, when it goes through the native stuff, it will lose its context, and you'll lose all your data. So you have to shim anything that that has native stuff within it. Like even the core HTTP stuff within Node, you have to shim. Like if you want to do a request out, you have to shim HTTP. But it's really simple. So there's a package called Shimmer, which was written by Forrest, and it's really, 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 really simple. So here's an example of wrapping HTTP. So you create this is actually from a shimmed file, a file that just shims this, and then you require that in, and it does it all before your application starts running. So you require an HTTP, you require in Shimmer, and then you say to Shimmer wrap HTTP, and I want to wrap the request function with this. And so this is just kind of all boilerplate. If you look at the Shimmer docs, then it will explain all of this. So we're starting our request. So this gets run every single time that request gets run. It kind of overwrites the original file and shims it. Yeah. So starts the request. It applies all the arguments that got passed in to the original, and then returns the new version, the shimmed version. But there are a ton out there that people have already made, and the likelihood of you actually having to write a manual shim is actually very low. So these are some that I use, but there's a load on NPM. If you just look at the dependence for Shimmer, because when you write a shim, you have to require in Shimmer, so you just look at the dependence in Shimmer. So there's a ton out there. So you can see there's bcrypt, there's Redis, there's MySQL, Bluebird, so that's Socket.io stuff. There's a ton of stuff on NPM already, and the likelihood of you having to do anything is actually very low, unless you're doing something really wacky. So, but you have to be wary about this. So there's danger. Danger, danger, danger. So this is the MySQL shimmer, for example. So it's doing stuff on private stuff within protocol, on the prototype before it gets instantiated. So you have to know about the stuff in the module that you need to ship. And you think, okay, well, we all should be reading our modules that we require in anyway, so that we know what it does. So that's not actually too terrible. What the danger is that internals of modules can change. As long as the public API doesn't change, people don't need to major version bump the module. So I can go in today with Node.MySQL, and that's, for example, I don't know, it's at 2.2, I don't know. And I can go in and change the names of every single internal function. As long as what is used publicly is exactly the same, I can go in and change whatever I like and just minor bump it, or patch bump it. What happens there is, if you're not protecting yourself properly, you can completely break your app by the act of shimming something that's not there, because it will completely fail. So, I was expecting another slide to be there. Okay, so yeah, it could result in a failing application. And I'm just going to go through to this slide because it talks about what I wanted to talk about. But everyone should be using shrink wrap anyway in their production apps, or another form of protecting themselves from modules that change, so that you don't install a module that you don't want to install. Everyone should be using some kind of mechanism. Whether or not that's checking in your Node modules into Git, which I hate, but a lot of people do it, and that's fair enough, that's how they want to do it. Pardon?
Why do you hate it?
I just hate the idea of it. Like, NPM's out there, shrink wrap's out there, you don't need to commit all of your Node modules into Git, because there are other mechanisms to make sure you don't need to add more stuff into your Git repository. That's my personal view. But people do it, and that's fair enough. But you should be protecting yourself in one way or another, so it shouldn't really matter to you that a module changes, that could change, because you're locked in. So the reason, the whole risk of a failing application is actually very low if you're doing production apps properly. So going back to what I should have then be talking about, so it also has a performance cost to a slight extent. Just because of the nature of how it works, the more namespaces that you have per function lifecycle, the more of a performance cost. I mean, we're using it in production in many apps, and we create one namespace, and we add data to the namespace, and that's it. And requests are generally short lifecycle, and we've seen no noticeable impact on performance. There's like, we haven't even tested it, like in terms of performance. The README tells you there's a performance impact, but because we haven't even noticed like a 1 millisecond change in our response times, we haven't measured it. What's the point? Does that make sense? Yeah? So, yeah, you need to keep your namespaces to a minimum and not abuse the system. It's not a Redis memory store that you can just dump a load of information to. It's designed to tidy things up of things that are used an awful lot or used throughout a whole request or throughout a whole kind of function lifecycle. It's not meant to be going to grab loads of data, put it all into essentially underneath. It stores it all in objects and within the async emitter. So it's, yeah, essentially you don't want to add loads of data into memory more than you have to. So yeah, you should all be using shrink wrap anyway, or some other way. So breakages should be limited, which means there's more bonus to actually doing it with very, very, very little risk, and there's a very low performance cost. Like I said, we haven't even noticed any performance cost in any of the apps that we've used it. And that's actually it. It's a very specific use case that does a very specific thing. But the more and more that I talk to people about it, the more and more I realise that no one's heard of it. So I'm pretty sure Forrest made it when he was working at New Relic, and that's how I think, at least their early stage New Relic agent did things. I think. I can't categorically say that. I've looked through some of the code and I can't see it anymore. But Forrest made it when he was at New Relic. So, so they were using it in, I'm pretty sure they were using it in their agent, which many people use. And as a company, New Relic can't impact the performance of your app too much, otherwise no one's going to use it. So yeah, no one's really heard of it, and that's really what I wanted to talk about and get people aware that they don't have to do some of this crazy stuff that many people actually end up doing. And the biggest thing for me has been those request IDs going off to microservices. I was speaking to someone earlier who said, well, oh, you should have talked about this at the microservices meetup yesterday. Because this would be really interesting for people in terms of microservices. And I didn't really think about it at the time, and it makes complete sense. That's how I use it. That we store an ID, and then we use it before we send a request off, and then in that request we send off the request ID, and that service then reuses that request ID, and that's how we get brilliant logs. Yeah, logging and microservices, that's really how we use it. But many people will find many different ways of using it. And yeah, that's pretty much all that I wanted to talk about. Thank you very much. Does anyone got any questions? I know I actually quite rambled on there. I just realised I got through that in about 20-25 minutes. So I know that I talked quite fast there.
So the question is, the way you tested, right? So you said you didn't really see a really big impact on the applications you run. But from what I see, is you essentially the question is, so what was the throughput of your apps at the moment when you were testing those? I mean, how many requests per second were you receiving per node?
So I don't think how many milliseconds were we saving by doing this?
It's not the same because maybe you could clarify on the. You said you didn't see how it affects, but you said. So did you refer to just one request you tested, or?
Oh no. So we went through load testing. We sent hundreds of requests to one node process, all at the same time, with and without, and we saw not enough of a change in response time other than the norm that you get within HTTP anyway, to warrant us actually spending any more time on what is the real performance cost of using it. We don't use it. We use it to store a request ID, and that's about it. So there isn't actually that much of a performance impact for us, just because of how we use it. If you were using it to store, as the example shows on the actual README, it shows going and getting a user's object from a data store and storing it. And then you could go and grab that 5-6 times throughout your whole application. If you've got like 5 different functions that need that data, you could go grab that data instead of looking it up again and again and again, or passing it all the way through and making your code ugly. That is a fairly big chunk of data, possibly, and therefore that would have more of a performance impact. The fact that we store a 32 length string means that we didn't see any difference in terms of load testing. Does that answer the question?
Yeah.
Yeah? Yes?
So if I was in a microservices environment and my services are distributed, does it offer any solution for distributed services, which are replicated, I guess?
So, are you talking about sharing data between the microservices?
Yes.
No, you can't do that. It's a store within the function's lifecycle, and that's it. Yeah, you can't share, you can't put data into one request, into one context, and then get it from a completely different context. So we have like middleware within our lifecycle, and right at the end, we check whether or not the context that we began with is the same context that we ended up with, because if they're different, it means that we lost the context at some point, whether or not that's a native module or whatever. We lost that context and we lost access to the original data. So yeah, you can't, as soon as something wacky happens, you lose your context. You can't share that context between function calls or processes or anything like that. Anyone else? No? Okay. Well, thank you very much.